Question number 3. Show that the curve have only one stationary point. Find the coordinate of this stationary point and determine its natural. Okay, so the dy dx for this is 5 over 3 and then 3x squared plus 8. So we have the 5 over 3 minus 1 will be 2 over 3. 2 over 3. Then we differentiate inside, we have the 6x here. Okay, so this one we cancel. So we have the 10x and then cube root of the 3x squared plus 8 power 2. Okay. Or I can say it is 5 over 3. No, this is 10x, the 3x squared plus 8 power 2 over 3. So, stationary point is the dy dx equal to 0. So we have the 10x cube root 3x squared plus 8 equal to 0. So we have the 10x equal to 0, x equal to 0. And this one, we have the cube root of 3x squared plus 8 equal to square. Okay, equal to 0. This is the other part. Then we will have the 3x squared plus 8 equal to 0. Then this one, no solution. Why? Because x squared is always greater than or equal to 0. 3x squared also greater than or equal to 0. And then the 3x squared plus 8 will always greater than 0. So no solution here. So they have one solution on it. So the dy dx is this. We want to know the natural, we find the second derivative. But to find the second derivative is difficult here. This one is dy dx. So what we do is, you can do it two way lah. One, find the second derivative, but I don't want. Okay. The second one is we have 0. So dy dx when x equal to 0, this is the x. Dy dx when x is 0, this is 0. And we have the negative 0.1 and 0.1. Substitute into the dy dx. So we have the 10 times negative 0.1 multiply with the 3 times negative 0.1 square plus 8 to the power of 2 over 3. So this is negative 4. And if we use 0.1 instead of 0, then it's 4. So we know that the shape for this is downward because the gradient is negative. Then horizontal positive, then it is upward. So these three combined will be like this. So the 2 0 here, this one is 0, this one is 0 0, so not 2 0. So we have the 0 something is the minimum. Okay, so it is a minimum point. So the question asks us to find the coordinate. So when x equal to 0, we need to find the value of y. So when x equal to 0, y equal to 0 plus 8 power 5 over 3. So 2 power 3, 2 power 5, 2, 4, 8, 16, 32. So this is 32, 0, 32. So we know that the 0.32 is the minimum point. Okay, so this one, to show that this is minimum point, is very easy. So what we can do, if you want to check, then it's very easy. Just that you substitute the value. Let's say we have the negative 1, 3 times the negative 1, the point nearby, negative 1 square plus 8 power 5 over 3 will be greater than this value. And then if we have 1, so they also same. If we have 2 here, then 140 something. And we have the negative 2 here, also 140 something. So all of this value is greater than 32. So we know that the 32 is the minimum value. But we cannot use this way to show it is the minimum. We can use either second derivative, okay, which you do the differentiation. So we have the differentiation of the 10x multiplied with the 3x squared plus 8 power 2 over 3 when x equal to 0. So we have 40. So second method is you use the so the second method is you find the second derivative. So d2y dx squared when x equal to 0 equal to 40, and this is greater than 0, so it is a minimum. Okay. So I use calculator to find the second derivative value. Is very easy. But for you, you have to do this. You have to use the product rule. So I don't want to do the product rules. So I use this method, table method. So we find the second derivative. So d2y dx squared. So we have a uv here. Then uv prime plus vu prime. So it's 10x 2 over 3, 3x squared plus 8 power negative 1 over 3, 6x, plus 3x squared plus 8, 2 over 3, 10. So d2y dx squared when x equal to 0, then 0 plus 0 plus 8 power 2 over 3 times 10. So it is 40, greater than 0. So it is a minimum point. Oh, this one also not difficult. Hmm. Because normally we will have something complicated, which is quotient rule. We have to use we have the something like d over dx for the u over v. Then we have the vu prime minus uv prime over v squared. Sometime this kind of question. So that's why I will normally use this